Hi everybody, welcome back. And you can see I'm well into starting this SX-1280 restoration. And I basically just took everything all apart and essentially did the old, if the part doesn't come out, you didn't take enough screws out yet. So there you go. I'm going to make a comment here in this video about these transistors because number one, I was wrong about a couple things, and I know that I did a few videos on transistors, and long time ago when I first started rekindling my interest in audio equipment, I started reading up on some of this generation of audio gear, especially this Pioneer stuff. And I read somewhere on the internet, because the internet's always right, isn't it? That these transistors, these output transistors, these 2SD746 and 2SB706 transistors, that they were a special type of transistor called a ring emitter transistor. And I have since found out that that is not the case. These are standard epitaxial deposited transistors, silicon transistors. And really the only difference between these and most other power transistors out there is the case style that they're mounted in and the fact that they are a higher frequency transistor. Now, there's only one almost illegible data sheet floating around out there on the internet for these. And it does give you some of the breakdown, but you'll read different things than you'll read in that data sheet. For instance, it states that the transition frequency of these is only about 15 megahertz, which is still pretty high for a power transistor. But if you read some of the comments on forums and things, they quote these as being a 30 megahertz component. I think part of that might have to be, once again, under what test conditions they're testing that. The other bigger thing, so I was wrong. These are not ring emitter, even though they have two collector terminals. That's literally just for wiring purposes. There's only one collector. It's a standard bipolar junction transistor, emitter base and collector. It's just that this particular case has two collector terminals. It has to do with wiring options and things. And I do think they did use that for a specific type of circuit, but that's as far as I know about it. The other thing that even, everything you hear out there is that this is a type MT200 case. That's the case style. Well, that's wrong as well, believe it or not. And I'm going to prove that to you in this video. We're going to talk about some of the weird transistors that Philips use, or that Philips, I was working on Philips equipment, X-ray equipment the other day, that Pioneer uses in these receivers. So first of all, this is an authentic MT200 case style transistor. It's made by Sanken. You've seen me work on these. And if you lay this over top of this, you can see it's pretty much almost the same size. They kind of, dimensions wise, they're almost identical. But here's the problem. If you look at the spacing for the mounting screws on here, and you look at the spacing on the mounting screws here, they don't line up. So if I put these on top of one another like this, you can see that if I line this screw hole up, look how far off I am. Or if I line this screw hole up, you see that? So you can't just go online and order a standard MT200 heatsink pad, a mica pad for that. And to make matters worse, on these heat sinks, they use this special design here, and they use a mica pad that has these little index pins cut into it so that it will hold hold it in place while you mount these things. So you can see how that mounts up there on those pins, and then the screw holes line up, and then you bolt that down to it. The problem is they use so much heatsink grease, which is actually not a good thing, that when they tightened it down, it kind of flexed the mica a little bit. And quite often when you go to remove these, you'll find that either they are cracked or they will crack as you're removing them. And even if you're super duper careful, you can see you just get little stress. You see these little dots? I don't know if you can see these little dots. These are delamination marks in the mica. This mica will actually peel apart and delaminate after a while. Not all mica is the same, and there's different qualities of it and so forth. Those pads are impossible to get. I'm going to show you how to get around that later on in the video, or later on in the series. But just understand that if you're going to work on one of these receivers, you're not working with normal components. This is a one-of-a-kind case style. And they used it in the 1280, the 1980, and the 980. They skipped over the 1080. For some reason, the 1080 uses a transistor that they also are calling an MT200, but it really isn't. It is what's called a bat wing transistor. And I have an example of those here. And what they look more like is a smaller, almost like a TO220, with a heat spreader attached to the outside of it. And you can see it still has a different spacing than these do. But because of that larger heat spreader, these handle a lot more power. They can dissipate a lot more wattage than like a standard TO220 case. So these will almost rival a TO3P case style, just in a smaller package. And you can see even these ones, the voltage rating, the current rating, and look, power dissipation 80 watts for this one little tiny transistor. So this one here is not compatible with the ones in an SX-1080. But it gives you, I just did this to show you an example. I don't have a lot of bat wing transistors like this. They call that because it looks like bat's wings hanging off of the body there. But these are also very difficult to find, as are these. And anytime you're going to work on any of those devices, the 980, the 1080, the 1280, and the 1980, you are going to have problems finding suitable replacement components that are drop-in replacements. Yes, you can go, everybody will list some company somewhere where you can still buy new old stock ones. And they'll say they're reliable, and they might be, but that's going to run out. I mean, as of this video, I'm sure there's still some available, and I have a small inventory of these, a couple of them, like maybe 4 or something like that, if I absolutely needed them. But really, what we're going to eventually get into is modifying the heatsink and the mounting system to replace these with modern, like TO3PL transistors, which are, much more plentiful than these, and you can get them in, in high frequency transistors like this. Like Sanken, like this company, still does make a few, although they are rapidly stopping production on their high frequency power transistors, so you better get them while you can. But anyway, as I was saying, this is kind of the world we live in today. So I just wanted to go over that and clear up any confusion. If you're doing one of these and you order standard MT200 mica pads, they're not going to fit. You're going to have to make them. Okay, and like I said, I'll talk about that later. Or you're going to have to be extraordinarily careful when reusing the originals. The heatsink grease on these was still fairly pliable and looked to be in decent shape. I probably could have left these mounted like that, but I wanted to remove all of this to clean. And again, I'm probably going to send these heatsinks out and have them completely refinished. This is not an anodized finish. It's actually got a painted finish on it. And I want this to look absolutely factory new when I'm done. or as close to it as I can do with my limited resources. And so I'll probably send these out and have them properly refinished. And I'll have them mask these surfaces off while they're doing that. If I can. I mean, I'm going to take it to the place that does that sort of work. If they think they can do it professionally, I'm going to do it. If not, then I'm just going to clean this as best I can and leave it alone. So I just want to go over that with all of you, and I'm now going to get started with I'm going to disassemble the other amplifier module, and then we're going to go over all of these, and we're just going to completely restore these boards. I have a bunch of parts from different from different sources coming in for different things I want to do with this amp. So as that trickles in, we'll do these individual parts. So that's what this part's going to be about, just kind of taking this down and restoring it. By the way, one more quick comment. I used some terminology about these transistors that I didn't totally explain. If you want to know more about some of these transistors and the different processes of manufacturing and so forth, go onto my channel and just go into the search bar and just type in the word transistor, and you'll see that there's probably, I don't know, maybe 4 videos or so, 3 or 4 maybe, related to transistors that I did over the years, and they explain a lot about what I talked about, because I don't want to kind of reinvent the wheel on this video. Okay, I'll move the camera out of my way here and do like a little side view for you. Hopefully you can see what I'm doing. And we'll disassemble this channel the same way as we did the other channel. And what I'm doing is I'm just kind of sorting my parts out here so that they don't get lost and they're mixed up, so you remember what goes where. And again, this is kind of tight to get this out of here, but you can do it like that. Then you have to kind of lift this up, turn it around, and you'll see there's 2 screws in here that have to come out. I'm trying not to bend the wires too hard. These are single, solid conductor wires, and while they're easy to pass through holes on the circuit board and they're easy to use on wire wrap posts and things, they don't really tolerate being bent back and forth very many times. They'll work harden and then they'll get brittle and they'll break. So I'm just always careful of that. And the first thing I always do, if you notice I did that before I even started the video, is I disconnect this stabilizer or stabilizing diode, heat, your thermal tracking diode, and I move it out of the way because it's just amazing how this gets caught on things and breaks. You just have to be really careful with it. I have, again, a very, very limited supply of a few of these for spares if necessary, but I try never to use them because they're very hard to get, and they're just going to keep getting less and less available. So we want to try to conserve some of these components as much as we can, and at the same time we want to try to find modern substitutes that will work in the same manner as the originals and require little, if any, modification to install. That's a tall order, and you can't always do that, but that's kind of the goal here on this vintage gear. And again, why Pioneer went to this extreme with these little circuit boards and all this, I don't know. It kind of looks cool and everything, but it can be a bit awkward. But it works for what they did. And I'm still at the very tail end of my cold. I'm not sick at all anymore, but every now and then I get a little bit of a frog in my throat. I have to clear my throat, but other than that, I'm doing really well. This part of the country, there's several different viruses floating around, and people getting the cold. You know, it's that time of year, cold and flu season as we call it, and it's to be expected. So I'm kind of glad I got mine out of the way early. I catch a good sinus cold maybe once every 2 to 3 years. I'll get one, and I'll have it for 3 or 4 days, and I'll go through boxes and boxes of tissues, and then it goes away. And there's all the different things people tell you to do, you know, the homeopathic things you can take and whatever. And you know what? It just has to run its course. Some things can help it go a little faster, but at the end of the day, a cold is a cold, and it's gonna, you have to just let it run its course and try not to let it get into anything bad. There you have it. So I just have some cotton rag here, and I just clean this heatsink grease off here, and you can see it's pretty pliable on this, which is good. But see how these ones have, you know, an exposed back plate. Some of them have a all plastic case, and they don't need to have any kind of insulator, mica or anything like that, but these ones do, as you can see. And you can see by the tarnish, see how it's tarnished around the edge? This probably does have some silver in the plating, and that also, silver's a pretty good conductor of heat, so that probably helps again with the, you know, thermal transfer to the heatsink. And there you go. So I just clean these off, and then I only have to get heatsink grease all over my hands one time. And yes, you could wear gloves too. That's another good idea. But usually I remember to put them on right as I'm finishing up, just kind of like I did just now. So anyway, so for this stuff, we want to be really careful with these mica pads. We don't want to damage them. It's a soft cotton rag, and I don't put anything on it. You can put a little bit of alcohol on it, and sometimes that'll, if it's really like sticky, gooey, you can take some, if I can find where I put it, you can take a little bit of alcohol and just put a couple drops on there on each one, and that softens this up quite a bit, and it makes it a lot easier to wipe off. So you just put that in there like that, and we wipe that. And the idea is not to catch the rag on anything. We're just cleaning the top surface first, and then we can remove the pad and clean the bottom surface. And I'll show you how to do that here. Everybody has their own way of dealing with this, and no matter what way you do it, there's always other ways. Just always remember that. The idea is do something that works for you, where you can minimize your risk of, notice I always go towards the edge from the middle. You don't want to go this way, because if your rag catches this thing, you know, it'll tear that mica right up, and you're done. Again, I'm not too concerned about that on this one, because I probably won't reuse these. I have a little better solution that I'm going to use, and I think it'll be better than using this. Okay, and see, I just touched this and it just fell off. So I'll just take that out of the way. That one's been wiped down already. And this one's all clean. I'll come back and take that one off here in a minute. And then I just have this one to do. Okay, put my microphone back on. So to finish cleaning these, I just take a nice flat surface like this little plastic thing that, you know, that won't catch anything. I put a couple drops of alcohol on there. I get another little piece of this rag, and then I just very gently wipe this stuff off. Am I going crazy? Yes, I am. But remember, these are unobtainium. You have one chance to make a mistake, and then you're done. So I would rather be overly cautious and take extra time than to do something the wrong way. I'll put that in the container with the other ones, and then I'll do the other 3. And then those will be, if I need to reuse them, I can. And I will probably, if I don't use them on this project, I will save them, because you never know if you're doing just a repair. You don't want to make any changes, and you want to keep everything original. It's nice to have those. So I will carefully store those away with my other thermal pads. And hopefully, if I need them, I got them. Okay, I've gone through and just tested the board, and any components that I am going to replace on this, I went back and pulled out of the bins and put them each in their own container. So I have one for the left channel, one for the right channel, and then I don't have to go digging for parts. They're just all here, and I'm just going to go through and we're going to replace all of the components on each one of these and rebuild these. The transistors are all good on here, and none of them are really ones that are super high failure, but I'm going to still replace these with matched pairs of 2 KSA 992s and KSA 1845s, just so I don't have to deal with these failing down the road. They usually will go into shot noise and things like that, get staticky. And if you remember, when we did the first test on this in the first video, you could hear both channels had a lot of static and noise in them. Part of that could have been the controls themselves, but something tells me not all of it was. And for what it costs for, another $1 worth of transistors, I'm going to replace them. I'm not going to replace these 4 right here because they're way overrated for their use. They're going to be just fine. But these small signal ones I am going to replace. None of them have tarnish on them or anything like that. This is a really clean amp. And of course the capacitors are going to get replaced. And I'm going to replace these potentiometers. Okay, so I'm going to end this part right here. And the next video I'm going to go into will be a solder and chat. I'm going to just replace these components, and we'll just talk about whatever comes to mind. How about that? You never know where those go, do you? If I didn't mention it earlier in the video, one interesting thing I found was that there were a couple differences between these two boards, and they are factory. There's been no service done to this receiver whatsoever. And that is, these resistors and these resistors, they're the same manufacturer, same part number, but you can tell they're slightly different. I mean, you look at these ones are gray, and they're kind of a little different body style. These ones are more like the ceramic coated ones, and they look a little more modern. And the same thing here, the capacitors they used here obviously are a little different than these ones. I'm sure the specs are all the same. But I noticed another video, or not a video, a post that somebody did on a forum where they did a restoration on one of these, and I noticed that they had that same thing. One channel had a different color resistor than the other. I don't know if that's just a weird thing, a coincidence, but I found it kind of interesting. I don't think it makes any difference whatsoever, but it's just kind of weird that the two boards were different. It must have been just when they built these two boards, whatever components they had. I don't know. But anyway, we'll leave that at that. And we have a lot of good, exciting work to do on this. I'm kind of looking forward to it. As you notice, the heat sinks are missing from the bench, and they went off to the refinisher. They were in extraordinarily good shape as far as not having any dents or bends or anything in them. The paint was starting to break down. Those heat sinks are painted. They're not anodized. And the paint gets soft on them after a while, and that's why they'll scrape and scratch very easily when they get old. And of course, just the fins on the edges of them all get scratched up. So I wanted to improve on that. So I sent those out. I'm going to have them high temperature powder coated. And I'm also getting the top and bottom cover redone. And then I'm going to refinish the wood case myself and probably fabricate a new set of, corner wood blocks that go on the sides, either side of the faceplate, because I really want this to look good. And I'm hoping the powder coating will be a little more durable than the actual paint. That we'll see how this turns out. I know it'll look beautiful. Let's see how good it turns out. I don't really have a good local source for getting them anodized, which to me would be even better. But we'll see what we get. And no, it will not make any difference on the heat sink's ability to dissipate heat. It already has a thick coat of paint on it, and the powder coating is actually going to be thinner, if anything, than the paint. I always get comments like that, get way off on tangents about little things like that. But it'll be interesting to see. So in the meantime, I wish you all peace, joy, happiness, and good health in your lives. It is now the end of the year. And as we enter into the new year, I have customers calling us on our days off, trying to schedule service for the January 2nd already, and we're all booked up. So I know this is going to be crazy time coming up. So like I said, this short video format, I'm going to try it and see what happens. It might work for my schedule. I'll just do a little bit at a time and then post it, and we'll see what happens. Anyway, until then, you all take care, and we'll see you again soon. Bye-bye.